Okay, I have had a number of requests. I think I have them all. Multiple requests to go over question 5 from the trigonometry homework. I'll start off with that one, no problem. We'll also be taking a look at questions 11 and 16. I've had multiple requests for 16. And asked to be looking at special triangles. Well, fortunately, question 16 will help us look at special triangles, so we'll be able to do that. I've heard a request to simplify rules, and I've had a request to look at question 4F, and a question 10 if we have time at the end. So, seeing as how nobody said anything about the exponents homework, I'm assuming this is all from the trig homework. Oh, which reminds me of something I meant to lead with off the top. My apologies to all of you who submitted your exponents pretest and then had nothing happen with it. A great number of you got them in. I discovered late today, about 10 minutes before class, that my notifications had been turned off. So thank you to the student who brought that to my attention. I've turned the notifications back on, and hopefully all of you who have submitted your exponents pretest now have access to the homework. Okay. Let's start by just refreshing ourselves on the trig homework. So we're going to start by looking at question number 5, which says determine the quadrant and the reference angle for the following. And I'm just going to make note of these really quickly. 415 degrees. 11 pi over 30, 330 degrees, 4 pi over 3, 115 degrees, and 9 pi for 10. Okay, I've just scribbled those down. I know they're a little blurry for you guys, but they're mostly there for my reference. I'm going to make it all a little bit more clear over here. When you're being asked to find the quadrant for something, sorry, I just realized I should have the quadrant and then the reference angle. We'll start off with the quadrant stuff because it's just a little bit easier to visualize, and once you've figured out your quadrant, then it's much easier then to figure out your reference angle. So, in order to figure out your quadrant, you want to draw yourself a reference circle of some sort, a unit circle. Okay, so this is your unit circle. That's your 0 point, or if you've gone all the way around the circle, it's also the point where you're at 2 pi. Okay? If you've only gone halfway around your circle, then you've only gone around by pi. Okay? And then doing it again, we're going to cut your pi and your 2 pi, or your 0 to pi in half. So literally we're at pi over 2 as we're halfway through. We can do the same thing going the other way. At the bottom, again, we're halfway between pi and 2 pi, which really means we're at 3 pi over 2. So far, so good. When we do something like that, now you've got an idea of where everything stands. The other thing you might want to do, again, because we're going to be dealing with radicals and degrees all at the same time, just remind yourself what this means in degrees. This is 0 or 360 degrees. This is 90 degrees. This one is 180 degrees. And this one is 270 degrees. So I'll start with question A, looking for 415. Well, 415 is larger than 360, so let's get rid of a 360 to start with. And when we do that, we end up with 55. 55 is between 0 and 90, which means it's in this quadrant. That's our closest x-axis. So we can actually just take it as red, okay? 415, our reference angle, is going to be 55 degrees. And we're in quadrant 1. Okay. Dealing with radicals. There was the question, should you turn these into degrees first? You certainly can. There's nothing wrong with taking all of your radicals and turning them into degrees and then going through this same process. But if you can also work with it in radicals, down the line as you continue your mathematical education, it just becomes a little bit easier. If you're not feeling comfortable with it right now and you're just like, I just need to get this under my belt to start with, go ahead and turn them into degrees first. But what I'm going to show you is that you can identify your quadrant actually a lot faster just from the fraction part when you're in radicals. So let me start with that. Taking a look at 11 pi over 30. 11 pi over 30, ignoring the pi part just for a second, 11 over 30 is pretty close to 1/3, right? It's one way to think of it. Okay, so we could say that's approximately pi over 3. And all you really need to know about that is that that puts it between 0 and pi over 2. Immediately, this tells you that we're in the first quadrant. Okay. And that means that your reference angle is going to be exactly where it falls. I'm trying to get this about right. It's actually not too different from our 55 degrees in this case. And then you can go through the process. It's going to, sorry, let me finish off that thought. Because we're in the first quadrant, whatever the angle is the reference angle, because we're immediately making our angle with this first x-axis. So we'll go ahead and we'll turn this into degrees. We've been through this process before. We know that 180 degrees matches with pi. We've done that there. And this then has to match with the degrees that we're trying to find, and 11 pi over 30. I know that's a little bit tiny. I'll make this larger as I come through here. So then what we're looking for are fractions on this. I'm going to put it in the easy form. I'm going to put x on top, 180 on the bottom. Will be equal to 11 pi over 30 over pi. The pi's are going to cancel. I end up with 11 over 30 multiplied by 180. Where did that come from? I'm jumping really quickly here. 180 multiplies on both sides so that it cancels on this side. The other thing we can cancel, 30 goes into 180 really nicely. It goes in 6 times. So we just end up with 11 times 6, or 66 degrees. Which is why I was trying to draw it pretty close to our 55 degrees here. Oh, you can't see that bottom part. There we go. we do the same thing going through all of this. I'm going to clean out some of this extra writing. So basically, your process the whole way through. 330, we come all the way around. We are there-ish. Our reference angle has to go with this. Okay, so we're looking to come back up to the 8 here, which means we're ultimately looking for that. How do we find that? 360 minus 330 is 30. So our reference angle is 30. And we're in the 4th quadrant. Okay, with this next one, you can't always do this, but I want to try and show you a fairly quick and easy way to switch between your radians and your degrees, certainly for all of your big easy numbers. So 4 pi over 3. If I had 3 pi over 3, I would just have a single pi. So 4 pi over 3 is just a little bit bigger than that, and that brings us into this quadrant over here. And so we're looking for this as our reference angle. So we have to just figure out, well, how much farther have we gone from pi to 4 pi over 3? I'm going to take some time, and I'm going to try and explain this in a long way, but the whole idea behind what I'm explaining is to make a shorter mental path between your radians and your degrees. So if this seems confusing, please ask me questions, because I want you to see this. Remember, our ultimate goal is to figure out what is this thing here? What is that angle going on there? At 4 pi over 3, let's give myself a little more space than that. We are some distance from our 180 line or our pi line. We want to know how far. Well, pi could also be written as 3 pi over 3 because anything over itself is just equal to 1. So when I take a look at this, I'm going to go 4 pi over 3 minus 3 pi over 3. That should just leave me with 1/3. Sorry, and that should be 1 pi over 3. The pi's don't cancel. I have 1 pi over 3, which is also to say just simply pi over 3. Pi over 3, looking at this really, really quickly, if I take pi and I divide it by 3, I could also make that the same as saying if I have 180 degrees divided by 3. Okay? Remembering that our ratio that was set up earlier when we convert between radians and degrees is 180 matches with pi. So I can replace that pi with 180 right away. And it just tells me that I'm immediately jumping down to 60 degrees. For those of you who can't quite see that. So if 180 matches with my pi, which means that I could say that this is 180 divided by 3. 3 goes into 180 60 times. So my reference angle becomes 60. And then because this is my 60 degrees here, I have to also remember that I'm going to be in quadrant 3. I thought the question is it only quadrant 1 where the reference angle is the same as the start angle? And the answer is yes, it is only in quadrant 1 where your reference angle. So only those angles between 0 and 90. Okay, So I'm going to do one more. I'm just going to do the 115 degrees just so that you can see quadrant 2 for a second, and then I'm leaving 9 pi over 10 for all of you to practice on your own without having been given the answers. There's still questions about it on Thursday. I'll go over that one again. So here we are at 115 degrees. 115 degrees is bigger than 90 but less than 180, so it's somewhere in here. Our closest x-axis is in here, so we actually want that part. So I'm going to take 180 degrees. I'm going to subtract my 115 degrees. And I end up with 65 degrees. So that becomes my reference angle, and I'm in quadrant 2. Any other questions on that before I move on? Okay, good. So next, we've had, in order of the questions that I have as they are listed, we're going to move on to question 11. This is largely a calculator question. So, using a calculator, find the approximate value of each of the following rounded to 2 decimal places. Again, a couple of ways you can do this. The first one is fairly straightforward. Whenever you're dealing with it in degrees, just go ahead and do it in degrees on your calculator. So if I have the sine of 28 degrees, now it depends on the calculator that you have. You're either going to push the sine button and then punch in 28 and hit equals, or you have to punch in 28 first and then press your sine button and then press equals. And it all depends on the calculator that you've got. However, if you've done it right to 2 decimal places, you should have, well, it's going to come out looking like this to start with, and it goes on and on and on and on. We only want it to 2 decimal places, though. The 9 tells us we go up, so we're at 0.31. The next question is asking for the tan of pi over 10. We can still do this with a calculator. And as I say, there are 2 ways you can do this. You can start by converting this to degrees first, okay? And I'm going to do it the fast way again. So remembering that pi can be translated into 180, we could say that pi over 10 is the same as saying 180 over 10, or simply 18 degrees. Okay. Then you can put that in here. Into your calculator, sorry, and you should end up with 0.3249 on and on, which for our purposes means 0.32. I'm being told my calculator did the wrong thing. Hold on a second. Let me just double check it. Sine of 28. Sorry, what did I write down? Oh my. You're absolutely right, folks. I'm not quite sure what I punched in. 0.46947, etc., which should be 0.47. My apologies, my calculator, or I punched something funny into my calculator. I lost the 0 because in my head I was jumping to the answer too quickly. Thank you for pointing that out. Good. This is the easiest method for doing this. There is a way where you can go ahead and you can do this with radians directly, but it involves making sure that your calculator is in radians. And sometimes, depending on the calculator, that doesn't always come out with consistent answers, I've found. So for the most part, this is the easiest way to do it. Take your radians, convert it to degrees, and plunk it back in. For the record, though, if you are comfortable using radians on your calculator, also make sure that you're using your brackets correctly. So in this case, if you're going to do this, if you put your calculator into radians mode, you want to make sure that when you're doing this, you're doing in brackets the tan of pi divided by 10. Just to be clear, up here, your calculator should be in degrees mode. And you'll still end up getting the exact same answer. Any other questions on that? If we're all good with that, I want to move on to question 16. So, coming down to look at question 16, find the exact value, if it is defined, for each of the following. Sine of 270 degrees. We want the tan of pi over 2. We want to look at the cosine of 0. And then we want to look at the cosine of 3 pi over 2. Okay. There's a bunch of interesting manual ways that you can go about doing this. But here's one of the things. If you find yourself being asked for the exact value of something, this generally means that you were referring to your special triangles. In this case, and I'm just suddenly remembering what I've done with all of these questions here. In this case, though, we're looking at some very, very specific things. So I want you to see where this falls on your unit circle first, all of these things, where they fall on your unit circles, so that the answers make just a little bit more sense to us. Let me flip back to my camera. There's our unit circle. 0 or 2 pi. There's pi. Pi over 2. And 3 pi over 2. And then, of course, in degrees, so we're also dealing with degrees. We're dealing with 0 or 360. 90, 180, and 270. Okay, so when it's asking for the sine of 270, that means that what we're looking at is right there, the angle that's formed when it's doing that. Sorry, that's not coming out very clearly. Let me see if I can make that a little more clear. When our angle is right there, okay? In order to work with special triangles, we're always working in reference angles, okay? Special triangles means reference angles. Reference angles are always between 0 and 90. So if I'm here at 270, that immediately means that my reference angle must be 90. Okay? So 270 degrees as a reference angle. Well, let's see if I can put some space there. Reference angle of 90 degrees. And funny things happen at 90 degrees because it's not really a triangle at that point. We don't generally take the angles of 90 degrees because when we're doing that, it means that our hypotenuse and our opposite are the exact same side. So we can't really do it. So I'm going to refer you back, excuse me, but I just need to switch screens. I'm going to refer you back to that supplementary sheet that I was sharing with you guys when we were doing trigonometry. And we have special things that happen here at 90 degrees. So you can see for the sine of 90 degrees, it's going to be 1. When we get to 270 degrees, it's -1. And I'll explain that one in just a second. But it's worth noting that at 90 degrees and at 180 degrees and at 270 degrees, 360 degrees or 0, you always get some funny things happening. You can see we're only at 1 or 0 where things disappear. This handout is available on the website. It's trig, I think I called it trig table brackets supplementary. Okay, so this table is actually going to give us the exact answers for all of the questions that we're looking at, but I just want to explain where the positives and the negatives come from. So remembering that things came out when I was talking about this, oops, you guys can't see what I'm doing. Let's try that again. This quadrant is positive, positive. This quadrant is negative, positive. This quadrant is negative, negative. And this quadrant is positive, negative. Somebody clever figured out what that means in terms of all of our trig values. Oops, wrong. Starting in the bottom right-hand corner, you can write the word cast. Okay? And what this means is, in this quadrant, everything's positive. A stands for all. In quadrant 2, it means that sine is positive, which means that when you're dealing with your reference angles and you have something fall into this quadrant, unless you're dealing with the sine of that angle, it's going to be negative. But if you are dealing with the sine of that angle, it will be positive. Moving into the third quadrant, tangent is the only thing that's positive. Everything else is negative. And then into the fourth quadrant, cosine is positive and everything else is negative. So 270 degrees tells us, well, it's right on the border, but either way, it's either in the it's either in the third or the fourth quadrant, which means that sine is negative. Okay? Because our sine is negative, our answer ends up being negative 1. Same thing ends up happening with each of these. With cosine of 0, we're going to end up at 1. And it's going to be positive because we're either in the first or fourth quadrant, and cosine is always positive there. Tangent of pi over 2 is undefined, or as I like to say, no. The reason for that is you end up dividing by 0. You're simply not allowed to divide by 0. Cosine 3 pi over 2. So again, we're going to be down here. I'm trying to remember if that one's a 1 or a 0. These things tend to slip my mind. Cosine 3 pi over 2 is 0. So for future reference, you can come back to this circle and you can work all of these things out the way that I was just showing you. Or, because somebody's already taken the time to do all of that work, make sure that you have available, particularly when you're in the test, that sheet. It'll help you with your major conversions between radians and degrees. Okay? And it shows you the exact values. Okay, question 4 was the next one that somebody was asking me for. So coming back up, find the smallest positive coterminal angle for each of the following. And we were specifically asked about this. So we're going to take a look at that. Smallest angle coterminal to 13 pi over 10. So given 13 pi over 10, our easiest course of action is first and foremost to convert this into degrees. I know immediately, because I'm 13 pi over 10, which is to say I'm a little bit bigger than 1, but I'm not as big as 1.5. I'm going to be somewhere in quadrant 3 here. Where exactly, I'm not sure yet. But we do a quick conversion and we'll find out. So this becomes 13 over 10 is equal to x over 180. We'll multiply by 180 on both sides. And that will come down to 18. 18 times 13 on your calculator comes out to 234. So 234 is somewhere in here. I'll say 234. And that is going to be your smallest, sorry, that was habit. I always, as soon as I'm doing something, I'm looking for the reference angle. Because I'm at less than 360, 234 is the angle that is coterminal. Oops, page. Okay, any further questions on coterminals? Or does that work for everybody? Okay. The next thing I have on my list is that I was asked to simplify the rules that I'd gone over in terms of the stuff that we had today with radicals. So I'm just going to make this really, really simple. Always simplify. One, simplify radicals, which is to say, if you've got root 20, that should actually read as 2 root 5. If you can make it simpler, make it simpler. No negative exponents. So if you have 1 over x to the negative 2, make it x to the 2. If you have y to the negative 5, you should make that 1 over y to the 5. And finally, no radicals in the denominator. So 1 over root 3 should be written as root 3 over 3. Okay. Next, I was asked to do question 10, and which should also cover off special triangles. So question 10, just to remind everybody, actually says, using special triangles, find the exact value of each of the following. So we're going to look for the sine of 30 degrees. We're going to look for tan of pi over 6. We're going to look for the cosine of 45 degrees. We'll look for the cosine of pi over 4. And we'll look for tangent 60 and sine pi over 3. I'm going to, what's going on here? So, I'm sharing the wrong thing here. Come on, computer. Really quickly, let's go back and look at those special triangles. Oops. Where'd they go? There they go. Okay. I'm trying to make these bigger, and it's not being cooperative. There we go. Oh, the resolution on that is poor. I will redraw them. Okay, let's get out of there. Okay, so really quickly, I just sketched those out so we'd have them here to refer to. This is your 45-45 triangle with 1, 1, and root 2 as your sides. This is your 30-60-90 triangle with 1, root 3, and 2 as your sides. So let's start at the top. It asks for the sine of 30. Let me just get our SOHCAHTOA down here. Sine of 30, so it wants opposite over hypotenuse. There's my 30 degrees. My opposite is 1, and my hypotenuse is 2. So the sine of 30 degrees is 1 over 2. This is asking now for the tan of pi over 6. Pi over 6, really quickly, it's like saying 180 over 6, which is just 30. So we want the tangent of 30 degrees. Tangent is opposite over adjacent. So for my 30-degree angle, my opposite is 1. My adjacent is 3. So this becomes 1 over root 3. And as we just learned, we're not allowed to do that. So it becomes root 3 over 3. Last one, I've just been made aware of the time. I've gone over time. So this is the last one I'm going to have time to do right now. Cosine of 45 degrees. Cosine is adjacent over hypotenuse. Here's 45 degrees. My adjacent is 1. My hypotenuse is 2. So that says 1 over root 2, which, as we just learned, is root 2 over 2 when we simplify it. Why? What did the answers in the homework say? Oh dear. Let me take a peek. Yes, because I see. No, it's not that the answers are wrong. It's just that for the time that we had put together the answer key, I hadn't established the rule with you guys yet that we were trying to simplify the denominator or rationalize that denominator. Now that we know that that's what we're supposed to do, those answers start to look wrong, but they are the equivalent of what we're doing, which is why I had the 1 over root 3 here, because that's what you're going to see in the answer key. I like that better. For the trig test, I'm okay with this, but after the trig test, we are looking for it like that. Does that make sense? Was that clear?